You know how in those sci-fi movies, people can just like disappear and reappear somewhere else?
Right.
Well, it turns out we're actually getting closer to that kind of teleportation,
Yeah.
but not in the way that you might think.
Exactly.
Today, we are diving deep into the world of quantum teleportation
Okay.
and a recent breakthrough that has huge implications for the future of computing.
Cool.
Our source for this deep dive is an article called "A Teleportation Breakthrough for Quantum Computing
Yeah.
is Here."
Okay.
So listeners, buckle up because we are about to explore how this discovery could literally change everything.
This is going to be a fascinating one.
So this article highlights a big challenge in quantum computing,
It does.
which is scalability,
Right.
building larger and more powerful quantum computers.
Yes.
It's so incredibly difficult.
It really is.
Think about like the early days of computers.
Okay.
You know, those massive room-filling machines?
Yeah. Yeah.
Quantum computers are kind of in that stage right now.
They are kind of in their infancy.
You know, the more processors you add,
Right.
the bigger and more fragile the system becomes.
You've got it.
Yeah, I can see how that would be a problem.
Right.
The article compares it to something straight out of science fiction,
It does.
which is a pretty apt description of quantum teleportation, I would say.
Yeah, I'd say so.
But, as we've hinted at, it's not about beaming people or objects across space.
Uh-huh.
So then what exactly is quantum teleportation?
So quantum teleportation, it's about using this mind-boggling phenomenon called quantum entanglement
Got it?
to transfer information instantaneously.
You're saying?
Imagine
Yeah.
two particles linked in such a way that they share the same fate, no
Mhm.
matter how far apart they are.
Whoa.
So any change to one particle is instantly reflected in the other.
So wait, are you saying like...
Yeah, think of it like having two perfectly synchronized mirrors
Wow.
reflecting each other.
I'm starting to get the picture.
Yeah.
So if you change something about one entangled particle, the other one changes instantly, even if they're miles apart.
Exactly. That's the core concept.
Oh,
That's
no.
quantum teleportation.
So it's less about...
We're not teleporting matter,
Okay,
but we're using this instantaneous connection to transmit information.
okay.
And this is the idea that researchers at Oxford University harnessed for their groundbreaking experiment.
Interesting. So let's talk about that experiment.
Sure.
What did they actually do?
So they were able to successfully use quantum teleportation to send a whole quantum algorithm
Wow.
between two processors
Okay.
that were 2 meters apart.
Oh,
And what's even more impressive is that they achieved a fidelity rate of 86%.
86%.
That means almost 9 times out of 10.
Wow.
The information was transferred perfectly.
So like...
It's like sending a long, complicated text message
Yeah.
and only having a couple typos.
That is really impressive.
And considering how delicate quantum information is, that's a big deal.
That makes a lot of sense.
Yeah.
86% accuracy does sound impressive.
It is.
But I'm curious, haven't scientists teleported things before?
They have.
What makes this experiment so significant?
So while scientists have experimented with teleporting quantum states before,
Okay.
this is the first time they've successfully teleported an entire algorithm.
Interesting.
Previous experiments were limited to simply transferring states between systems.
Mm-hmm.
So it's kind of like sending a single letter instead of a whole message.
Okay.
This Oxford experiment really represents a major leap forward in terms of complexity and sophistication.
So this is where it gets really interesting for me.
Okay.
How does this breakthrough with algorithms help solve that scalability problem we were talking about earlier?
So imagine instead of trying to build one giant, incredibly complex quantum computer,
Mm-hmm.
we could use quantum teleportation to connect many smaller, more manageable processors.
Right.
This would allow us to create a distributed network of processors,
Oh.
all working together like a single powerful machine.
So it's like having a team of smaller computers all linked together, sort of like a quantum internet.
That's a great analogy.
What are some of the potential roadblocks or limitations to this approach?
So there are definitely challenges.
Okay.
Figuring out how to reliably connect a large number of processors,
Sorry.
maintaining entanglement over long distances,
Yeah.
correcting for errors,
Right.
just to name a few hurdles we need to overcome.
If we can overcome those hurdles, it sounds like we could potentially build quantum computers with almost limitless power,
Absolutely.
especially given that current processors are limited to around 50 qubits.
That's right. To tackle truly complex problems in
Yeah.
fields like medicine or materials science,
Right.
we'll likely need thousands or even millions of qubits working together seamlessly.
The aliens.
And this teleportation breakthrough could be the key to unlocking that potential.
That's incredible.
And it's important to remember that even with current limitations, quantum computers are already achieving some incredible things.
Speaking of incredible things, didn't Google's Willow chip solve a problem in just 5 minutes?
It did.
That would have taken a supercomputer quadrillions of years.
Quadrillions.
That's mind-blowing.
It really is. It's almost impossible to even comprehend.
That's a great example of the power of quantum computing.
Yeah, it really shows you what they're capable of.
It really makes you wonder, what other seemingly impossible problems will we be able to solve in the future?
I know, it's exciting to think about.
So to recap, we've learned that quantum teleportation, which is all about transferring information, not matter,
Right.
could be the key to overcoming the scalability challenges of quantum computing.
It very well could be.
And even with current quantum technology already achieving such incredible feats,
Right.
the future possibilities really do seem almost limitless.
They do. It really does make you think, if we're already seeing such amazing results, imagine what the future holds.
Yeah.
You know, how might these advancements in quantum computing revolutionize fields like healthcare materials, science, artificial intelligence, even our daily lives? You know, it's something to ponder, isn't it?
It really is.
Yeah.
Thanks for joining me on this deep dive into quantum teleportation, listeners.
My pleasure.
Be sure to check back for more fascinating explorations of cutting-edge science and technology.
See ya.
Until next time.
Bye.